Okay, so good afternoon. And the topic of our today presentation is LinkMove and synchronizing your data. And also we'll talk a little bit about domain-driven design, DDD. So I showed this slide yesterday. I'm an open source developer. I write lots of open source code. This is one of the open source projects that I had a hand in, and I run this awesome company called Object Style that can help you with Boutique, Cayenne, LinkRest, LinkMove, all our open source stack. We can train you in that, or we can actually write the apps for you. Okay, enough advertising. Let's talk about domain-driven design. And this is not a domain-driven design talk, so this is a pretty deep topic. And how many of you have actually heard about domain-driven design or read one of these books? Okay. So the blue book, that's a classic one that was written, it was published in 2003 by Eric Evans. And anybody I asked, including myself, actually, they never finished reading it. Like many people started and just, couldn't finish it. And that's just the way the book is laid out. I mean, it's a long discussion about actually some pretty interesting topics, but all the core ideas of domain-driven design, the strategic modeling, and all those good things, they're in the last chapters. So you actually have to go through a lot of material until you get to the gist of it. So the second one, implementing domain-driven design, it's an easier read. It's lots of practical advice, and it explains all the concepts in the beginning and then goes to practical advice as opposed to just telling a long story with some happy ending. So if you're interested in the topic, I mean, I'd recommend maybe starting with the red book. So, domain-driven design, in the context of this talk, it helps us to define some vocabulary. Even though copying data from one place to another, it has nothing to do with domain-driven design as such. But we figured out, when we looked at our solution, we didn't create it with domain-driven design in mind. But when we looked at it after we already had it, it turns out that it fits nicely into some of the DDD ideas. So this is why I'm tying the two together, and this is why I'm starting with explaining what domain-driven design is. So let's consider like any organization. I have an example of a sports organization, but it can be any business. Any business has its characteristics. So if you try to model your business, and you probably know it better than I do, so you can easily, you can treat your entire business as a single business domain, right? And you can probably easily identify pieces within that business that are logical subdomains, probably aligned with your departments. Everybody has like HR, finance, and so on. I mean, small businesses don't, but these functions are still there. I mean, you're still solving the same problems as like big corporations, but on a smaller scale. In a sports organization, we have probably, I don't know, dozens of these circles. I'm just showing 4, but there's really like many of those subdomains. And if you consider a sports organization, so everything revolves around the schedule. So whatever happens inside a sports organization, usually it has something to do with the season and how games are played, and on what dates and in what locations and so on. So scheduling is kind of an important subdomain. Website is another important subdomain. That's how an organization just talks to its fans, and it's not just website. I mean, it can be also web services that serve like web applications or other native mobile applications. And so on and so forth. So that's a front-facing part of the organization. Then there may be venue operations. Those are people who go to the arenas and make sure that everything is ready for the game, and so on and so forth. So obviously those people need to know something about the game schedule. Then there may be officials management system. There may be some other systems, and all of those systems, all of them operate in a single like top-level business domain, but they're dealing with very specific problems. And if you start modeling it, very often you would like to, you would see that those subdomains, they really share a lot. So if we talk about sports organization, of course, there will be games, there will be teams, right? And they will be everywhere. So whichever part of the system you start writing, there will be a game object. Like at least, I don't know, 90% of those systems that I've seen in the NHL, for instance. So again, it's very tempting to create some mega models that has this game objects that describes everything everywhere. But this won't be a good idea because in addition to the overlapping parts, there are lots of distinct parts in different subdomains, meaning that if you put them all together, you will get a model about everything, but also about nothing, and a model that's very hard to reason about. And domain-driven design is all about establishing something called a ubiquitous language, so a language that developers can use to talk to the business users, and so that we don't try to explain, like I don't know what a factory is or whatever, what dependency injection is to a business user, so that we actually focus on solving a business problem. And this has been the problem in the whole of my career, where you kind of practice object-oriented programming, right? But at the end, your objects are not something that you can actually tell your business user, so I have this object here, this is how it behaves, because your object is probably something factory, and what is that? Or a decorator or a wrapper, or some internal concept that's really specific to the implementation. It's not specific to the business. So domain-driven design, it's a good idea. I'm not even saying that you can that they solved this problem completely, but they're trying to solve it, and this is why I like it, not because I can just start applying it. So they say that your model should be done in the terms that you would use when talking to your users, and they will understand it, and when they talk back to you, you can translate this directly into software. That idea leads us to the thing that we need to model our subdomains separately. We shouldn't try to create a mega model for the entire enterprise. And those models and the software that comes around them are called bounded contexts. And usually bounded context, like in a normal developer terms, is just a bunch of applications that have their own database that is not shared with anybody, so only these applications actually work with that database. I mean, it doesn't have to be a relational database, it's like some kind of data store. So essentially that's like a world in itself. So the bounded context is a system that's in a way self-sufficient. Of course, it interacts with the rest of the enterprise somehow, but it's an isolated stack, so to speak. And this is the part that's important for this talk. So there are lots of other good ideas in domain-driven design. They have the ideas of like strategic model and then like tactical parts, and all of them are there are some good ideas that you can just take and use them one by one. But this is a strategic part where you split everything into bounded contexts and you work within that. But they need to interact with each other, right? So no one is an island, right? So they have this overlap in models. And for instance, if we talk about scheduling, it means that if a schedule is created in one place, it needs to somehow propagate to other bounded contexts. And if you don't use domain-driven design, you will still see this in your organization, where you have system A that produces some data, and you have system B that needs to consume it, but not just consume it. I mean, it needs to transform it before it can consume it, and do some manipulations with this data. So this is where, and looking at the theory of, within the DDD community about integrating those bounded contexts, integrating those sort of independent systems within an organization, you would find two things that people recommend. First is REST services. So like a source of the data, it exposes this data via REST service, or I don't know, SOAP service or something. And second is to use messaging. So when data changes, the source system, it broadcasts a change event, and it can be received by anyone within the enterprise and acted upon accordingly. So for instance, they can go back and call the REST service to refresh their model. So this is all good, and this is sound advice, but it has certain real-life limitations. And the first one is that not every system, not every legacy system has REST APIs that you can consume. So you have lots of systems that weren't designed, with sharing in mind, but sooner or later somebody comes in and says, I need this data. And the second thing is that, of course, any system can change over time, and it will change. If it doesn't change, it's probably, your enterprise probably doesn't need it. I mean, there's no reason that it should be there. So every live system, it changes all the time. And the consuming side of it, I mean, it needs to build some kind of anti-corruption layer to be able to keep consuming this data when, as that goes through versioning and so on and so forth. So you need to consider that when integrating. And finally, there's an issue of a quality of service. So what if the system is down and we need this REST? So our client, for instance, it goes to 10 different places and grabs data from all across the enterprise. And of course, out of those 10 places, there can be like 2 that are currently down, and you need to wait when they get up. And what do we do? So should we stop and give an error message, or I don't know? So all these things they need to be considered essentially when integrating. Somehow, there is a nice thing out there called ETL, extract, transform, load, and that's an old thing, and that's just essentially a data copy mechanism with transformation in between. Somehow the ETL approach is not mentioned as one of the integration strategies. I think it's not pure enough, I guess, because it exposes just too much of the source system, meaning, so in DDD terms, you shouldn't show the implementation. Just like in object-oriented programming, you shouldn't show the implementation of your object. You should just interact with the object with using its methods. The same idea applies to bigger systems, to the bounded contexts. So you shouldn't tell your consumers how it's organized, because you can change that. So I guess that's the reason why ETL is not used, but we're all like practical people, so we break all kind of rules. And so ETL is just very easy to implement on a legacy system. You don't really depend on another development group to develop REST APIs that suits you. So all you need is for them to give you a database login to their database, even if it's read-only. And second, I mean, it has a built-in anti-corruption layer just by definition, because ETL is that adapter between system A and system B. So being an adapter, there's some programmable way of adjusting when the source changes. And finally, its target is usually persistent data store, a database. So you always have at least hopefully fairly recent copy of the data from another system. So if that system is down, the whole ETL process is asynchronous. You don't do ETL it's not initiated by a web request. So you always have a fallback strategy when the source system is down. You can work with stale data for a while, until it comes up and you can resync. So ETL seems like another good solution in our tool set for integrating different systems. But of course, it also has its own challenges, just like everything. And most ETL literature is talking about data warehouse again. And data warehouse is a very special target store. So it's intended to get lots of garbage in and then do some analytics and provide some charts to the management. So we're talking here about application databases. Our targets are not data warehouses. So our target databases is our normal databases that our apps access. And most existing solutions are not open source, and the one we've seen, they're all standalone services that require their own programming. So essentially, so you will add another system where you need to model everything. You need to model the source, you need to model the target, you need to model the transformation and do its own deployment, and it's not synchronized with your own development. So if your database changes, you need to somehow update your ETL system. So we decided to do something that we can use, something that's practical in our situation, and we didn't even know about DDD back in the day. I mean, we've heard of it, but we didn't analyze it from that angle. but the end solution, the end result, it turns out that it's very suited into this DDD scenario of synchronizing bounded contexts. So getting data from one context to another, and adapting this data to your target model. So we created LinkMove. It's on GitHub here, NHL/LinkMove, and LinkMove is just it's just a bunch of tasks that you usually put in a job, so that runs periodically, right? And the target, the output of LinkMove, so it's a chain of it's a pipeline. So there's like data comes in and data comes out, and the target of that pipeline is usually a database. But we're thinking about like maybe adding some other data stores, or we may write this stuff to Kafka, for instance. So I don't know. But the source can be anything really. And the easiest thing to do is relational database. But well, actually, I can't say it's the easiest. So we can consume any data source, and these are the data sources that we can currently consume, including like Active Directory, for instance. That's a very popular one because like every system, in addition to games, it also has users. And where do users come from in the enterprise? They come from Active Directory. So user profiles within each application, they're synchronized using LinkMove. But then it can also consume REST services, so we don't deny like other ways of using other integration approaches. And we have an idea of extractors. So extraction phase is described in XML, and we will see it shortly. And the good thing about extractors, that's our anti-corruption layer, because they can leave, while you can put it right inside the app, it usually lives on the file system. So if somebody went and in your target database renamed your game table, you can actually quickly you can identify all the extractors downstream and go and quickly change them without even restarting the apps that are consuming them. So let's do a little demo. So this is our schema with game and team table coming out of scheduling system and go into our website system. So let's do some live coding here. I don't start from scratch here. I'm using an existing project just to show how we're embedding LinkMove jobs in existing apps, essentially. So it can be its own app, but you can actually put it in any other Java app, and it reuses a Cayenne model. So if this is an app that I have here that has the target schema, the website schema, already modeled in Cayenne. And the beauty of it is that we reuse this model, we keep track of the changes in this model, and we update LinkMove together with the rest of the application. And of course, this is a boutique app, and it's a job boutique app. We haven't seen those yet, so let me show you the POM. So in the POM we have Cayenne, we have logback, but we also have boutique jobs. That's another module that allows you to run either scheduled jobs or just jobs that you can run once from command line. You can probably put it in cron, so essentially use either external scheduler for jobs or use internal scheduler built into the module. And in the app, I already have a job, but it doesn't do LinkMove yet. It's simply, it runs some Cayenne query. And we will change that. And this is how we contribute a job to job module, kind of like we did contribute REST endpoints to Jersey module. So we contribute jobs. And let me actually run that and see if it works. Run as Java application. And job module has a number of commands and options. The important one is exec, so it executes job once. And there's also a schedule, but we want to use that, and there's a list that shows all available jobs, so it tells you like what's in this app. It's very useful for admins. They can see like, this app contains these jobs, and you can actually pass the job names. So we're gonna do a single execution. So we'll do exec, and we'll do job, and we have a job called sync. And we probably also need need a configuration file because it connects to the database. So here's our configuration file. So it has a website database there, and it has, so we saw it yesterday during boutique presentation. So that's boutique configurations that configures data source and configures Cayenne. So we'll use that. Apply, run. Okay, it runs a job and it finished. The app exited, and it didn't return any data because our target database is empty at this point, and our source database is Postgres. So it has sgame and steam tables, and our target database is MySQL. So it really doesn't matter what type of databases we have, and data sources can be anything. And right now, the target is completely empty. Since we have dependencies between tables, the first thing we need to synchronize is teams. Once we synchronize teams, we can synchronize games that depend on teams. So let's go and quickly import LinkMove. So there's another boutique module, and again, LinkMove can be used without boutique. But just like everything, it's easier to do it with boutique. So we import boutique LinkMove, and we remove all the Cayenne stuff because LinkMove already knows about Cayenne on its own. And we will inject an object called LM runtime. And if you're not using boutique, LM runtime is something that you will still use to bootstrap your LinkMove tasks. And we inject it right in the job. So dependency injection works on all the objects that we operate upon. Inject. And in our job run method, we create something called LM task for the team. So we'll call it team sync. Runtime, get task service. And we have different types of tasks because there are different algorithms involved in synchronization. The most commonly used one is create or update, which does exactly what it says. So it compares the source and target and creates new records in the target that are not that are not there yet, or updates those that are there but have changes in the source. And it's all type safe. So we say we synchronize in W game. We can specify other things here. The important one is Extractor. An Extractor, we haven't seen Extractors yet. Let me do a quick copy of Extractors, so I don't want to write XML here. Okay, so I'll copy a bunch of Extractors at once. We'll look at them one by one. So here's our team Extractor. So its goal is to map the source to the target and provide a query for the source. So here's our mapping, and it uses Cayenne expressions for the target because target is Cayenne, source is not Cayenne. Source can be Cayenne, but it's sort of irrelevant to us. We just use Cayenne as a JDBC framework essentially for the source. But target is Cayenne, and we're using Cayenne expressions. So if we want to map ID that is not an object property, so here ID is, it's there, but it's not an object property. So we use a DB pass expression. That's a part of Cayenne expressions API. And this is an object property, so it doesn't need a prefix. And this is a SQL query against the source. And this is also a Cayenne SQL template, means that it's scriptable. So first level of customization you have is that you can write any SQL against the target database, so a SQL of any complexity. And second, you can also use velocity templates to do dynamic things inside the SQL. You can pass parameters from the Java code through that. And yeah, so scripting is mostly used to pass parameters when we are writing our task. But here it's very simple, right? I'm just selecting a bunch of columns, and we need to reference this extractor here. So it's a schedule, team Extractor XML, and we do task. So okay, so we have this task, and we can reuse it as many times as we want. So once we create it, we can save it and then run in different situations, run with different parameters. For now, we will run it without parameters and just synchronize everything. So we do team sync run. It returns an execution object. Team result, and we can actually print the results of a LinkMove run. Team result, create report, so it just gives us a map of various information. What else do we need here? We need a driver for Postgres, because right now everything will run from our application, and it will connect to both MySQL and Postgres. I'm gonna steal it from here. Put it in the POM, and we will need to go to our boutique file and add a Postgres data source information, and the names that we need to assign to it comes from the extractor. So here we have a connector ID called scheduling. So we are configuring a connector which happens to be JDBC connectors, and it will look inside boutique for a data source named after the connector ID. So here we call it scheduling, and since this is YAML, it's space is meaningful. Okay, so we have this in place, and hopefully it will run now. Okay, we have an error somewhere, and that's because we're synchronizing a team, but I told it to synchronize a game, so that's not right. Okay, be a little better this way. Okay, so it synchronized all the teams. As you see, there's a big insert. It inserted all like 30 NHL teams in the target, and we have them here now. So this task worked, and the task is idempotent, meaning that if I run it again, nothing will happen because the source hasn't changed. So if I rerun, nothing happens. It just analyzes the data and says success. I mean, this is it. Now let's go ahead and synchronize our second table, games. So now we can just copy paste stuff. Game sync, and we game. We use the game extractor. I'm not even showing it. I mean, it's very similar, and the game result. There are many more games than teams, and we might want to optimize this a little bit and add a batch size to our game sync. Oops, not here. Make it small, but default batch size is actually using batching by default, but default batch size is 500, and I want to show the logs in smaller chunks. So let's run it again. Okay, so we got an error, and this is where we need to write some kind of adapter, because our target game, it has columns that the source game didn't have. So it has scores, and the scheduling system doesn't care about scores. Scheduling system cares, when the game is played, where it's played, what teams are playing. So scores is out of its scope. And the website, of course, it does care about scores. So we have an object that requires scores, and those are not null. So we got an error. And there are different ways to fix it. We can just go to the game extractor and we can add like 0, 0 right here, right? So SQL allows us to do that. We can write this adapter using SQL, or we can do something fancy. We can write a Java listener that intercepts in the between the stages of a link move and actually does a transformation. So let me try to write in the Java listener. Static class game listener. Doesn't implement any interface. It's just based on annotations. And this actually makes it hard to remember like how it should look like, because the method signature is really up to you. It's not enforced by any interface until you run it. Public void, okay, fix games, execution, and it takes like a stage context, which is called create or update segment, and it's called segment because we're using batches. So it just alludes to the fact that once we process the incoming stream. So that's a context of a single batch. So it's called a segment, and here, and we need an annotation to attach it to a specific stage, and they all start with after and the stage name, and it's really not important what the stages are at this point, but if I remember correctly, so we need this stage when we already have target objects, so we can modify them. And here we'll use some functional programming again. Map, and what does it return? Create or update tuple. Nice. So we get the target, we get our game. So the create update tuple is just a pair of source and target. So we get target, and then we do for each, and we have our game, and we set the scores. And we don't. Okay, so we need to add a filter also because we don't want to set the scores on updated games. We want to set them on new games. So the filter is we're using Cayenne API, and the filter will be game get persistent state equals persistent state new. So we're just checking the state of the object. I don't remember if EOF, it probably also has the states of the objects. Does it? How do you tell if it's new? Okay. So so here we just do game set away score 0. Set home score 0. So I guess it's I should have probably used SQL. It would have taken less time in this case, but it shows the listener. And now we add the listener, and now we can rerun. It fails again. Something else. Invoke virtual. Doesn't like my listener. Class is not public. Okay. Okay, it works better this time, and we have a bunch of games, so it runs all the batches like one by one, and in 20 games at a time. And at the end, we have our report that says that there were 1,230 games extracted and 1,230 games created. If we rerun, of course, nothing will happen. I'm not sure why my monitor behaves like that. But if we actually go and change some games, so updates will definitely come in. So if we go and change the game time, for instance, in Postgres, so we are looking at the source, and we save changes and we rerun. So it's mostly selects, and there are a couple of updates at the end, so it updated 2 records. So cool. I mean, that part works. One thing that is still missing in our game team synchronization is what if a game is deleted from the schedule, and it doesn't happen that much during the season, I guess. But sometimes they put something that they want to remove, at the start of the season. And creator update doesn't handle that. So it keeps adding data or it keeps updating data. So we have a special task for that as well. It's called delete. So instead of creator update, we do delete. And we don't care about the listener. And the extractor is called something else, because extractor actually, if you think about the algorithm, so when we actually doing creator update, we go from, we fetch, like, say, 500 games from the source, and then we check whether the target contains any of those. So but when we check for deletes, we do the opposite. We actually start fetching from the target, and we have a target stream, and then we compare it with the source. So we do it in reverse. But the same extractor actually works, but in this case, not in all cases. So the extractor is called source match extractor instead of just extractor, but it's the same extractor. So extractor is the same, but the algorithm is different. And we have the game delete result. So that's how you delete games. Okay, let's delete a couple of games and run it. How do you delete in this interface? Delete row, save changes, run. Okay, so that deleted game, it's gone from our target now as well. We have full synchronization right now. We are running completely in sync with another system that where games can come in at any time. So we schedule this job, and it keeps updating. Let's go back to the slides. So as you see, LinkMove, first of all, it's embedded in your app. And with Boutique, we actually started writing separate apps that are doing LinkMove. We package all the LinkMove jobs within a given domain in one app, and we just put them in cron or use Boutique scheduler. But initially, we actually even put them in web apps, and it works really well. And but the important part is everything is in the same version control as your application code. Except I guess when you want extractors to live on their own cycle, so you can put them in a different Git repo, and you can actually update them when the source changes. That's your anti-corruption layer. So when somebody renames the source, it's all driven by Cayenne ORM model, so you don't need to model the target at least. I mean, you only model the source, and then. It can work with any legacy source. It can work with any data source really, and the architecture of that LinkMove is, what's beyond the API is connectors that allow you to connect to the data source, and extractors that allow you to make sense of that data and do something with it. So actually provide it to LinkMove pipeline. So this is the connectors that are available right now, and you can easily add your own. And extractors, some of them are similar because to read a JDBC data source, you need the JDBC driver to connect, and then you need to use result set to obtain the data. So it's also called JDBC, LDAP. But then from URL, you can read many types of content. So we have extractors for XML, JSON, CSV, and so on. And how about actually synchronizing our scores from yet another data source? So, for instance, at the arenas, they have this live scoring system where people are sitting. There's a bunch of people in a dark room, on top of the arena, looking down. And when events happen, they actually enter them in their laptops, and those things they go into some feed, to whoever is consuming that feed. So our website changes almost in real time when somebody scored or somebody got a penalty. All the game events, they're tracked in close to real time. So part of that scoring system, it provides us the scores, and of course, that's a simplification because those models are pretty complex. So I can go back to the demo and emulate our JSON data source with just a file. So this is just the same file that was on the slide, and we can add another extension to LinkMove as it works with JSON. By default, we don't include all the connectors because that's like lots of dependencies to carry around. So whenever you need something special, you add it. So LinkMove JSON adds you JSON capability, and we write scores task. We also synchronize in the same table, but different set of columns, and we use a different extractor. And extractor looks different. Instead of SQL, it has this strange expression down here. And it's actually documented. We use in JSON pass. It's not a formal specification, but that's something that's used pretty widely. So we run in game scores. Game scores, and we do it here. We do it after everything. After we already have a clean set of games. So let's see if that works. Okay, that's all our previous synchronization. I'm rerunning it, but here is the scores part. So it actually updated a bunch of scores. So here it starts here. We'll use Extractors. There's a word missing in there. But at the end, for that extractor, we have 3 updated games. And so we have 2 different data sources updated in one table, and 2 different, bounded contexts that are providing data to our bounded context. So let's quickly go through LinkMove, through like LinkMove capabilities, because we have to deal with different kinds of data. Some of it maps easily to our model, some of it doesn't map at all, or it's very hard to do it. So we used implicit matching between source and target. So we relied on the fact that the source system and target systems, they share IDs. In many cases, that's not so. Like for instance, we have game tables in certain contexts. Like for instance, we have an official tracking system that has games from other leagues, not just NHL. So we have to use a different ID, and we synchronize them from different pieces, different places. So you can actually match by any unique attribute, really. But you need to tell LinkMove explicitly that this is attribute to match upon, and this can be a combination of attributes, so you can pass multiple attributes. Or you can write something called a mapper that essentially this is a mapper of both source and target to some keys that you can compare. So it gives you keys on the source end, key on the target end, and then LinkMove algorithms can just compare those keys between source and target. And also it asks you to provide like a way to build a Cayenne expression. So this helps us with batches, because we want to select a bunch of things not just by ID or whatever, but we want to select the whole batch at once from target. And the last method, the expression for key, helps us. This is a custom mapper. Now transformation. So we are dealing with ETL, extract, transform, load, and transform phase is just as important as extract and load. And we've seen how we can transform things with a listener. So there are lots of cases when you want to transform your data, really. I mean, because data can be bad, or it just needs to be adapted to our target. So the simplest way is to transform inside SQL, transform inside Extractor. And the first example is SQL. Of course, that's pretty straightforward. The second example is actually synchronization from Active Directories. That's LDAP. And with LDAP, you cannot do. We can do all this fancy stuff with transforming the data, but we can do one important thing. We can do filtering, because LDAP trees are big, and people put random accounts in random places. So we discovered that we need lots of rules to actually get the set of users out of LDAPs that this application needs. And this helps a lot, I mean, because we don't need to deal with all that in Java code, so we just, script it in Extractor. And we can change it when something changes on the AD end. So when an admin goes and creates like a new organizational unit, we can add that to our transformation without recompiling the app. Transformation with listeners. So this is something that I showed already. And we have a bunch of stages in the pipeline, and again, don't read too much into individual stage names because we can change it tomorrow. We're really like, pipeline is flexible, we extend it all the time, but between any two stages we can insert a listener, and it has of course all the data available from the previous stages, and it can do whatever it wants with it. I mean, it can, before it goes to the next stage, it can wipe it out for what it's worth. So this is a very powerful API to actually interfere in the pipeline. Now performance optimization. So we've seen batching, and of course not using batching is bad when you process an unbounded stream. So you either process objects one by one and then everything is very slow, you have to commit after every object, or you don't commit and they keep accumulating, and after like a few 100,000 objects you definitely crash. So batching optimizes it, and it's on by default. And another optimization that's still not there, but it has to be, really, is actually running batches in parallel. There's nothing that prevents us from doing that. So you can just start reading the stream and then like do all the processing, run the whole pipeline on a thread pool. That's something Yugi was showing yesterday, and this is how it should be done, and that's one of the important improvements that we're looking to do. But before we do that, you can also parallelize your LinkMove jobs. As you've seen, like a job can be made of multiple tasks, right? So you need to synchronize multiple tables. So this is the beauty of Java 8. There's a thing called completable future. So that's just a Java 8 examples that I like. So consider, consider, for instance, that you are synchronizing, in addition to like games and teams, you synchronize in the rosters. So who is playing in a particular game. And for that, you need to first synchronize games. Second, you need to synchronize players, right? There is a table of players, and only then you can synchronize your roster, because only then you have all the objects in place. But games and players, they don't depend on each other. So the list of games and list of players, they are independent. So you can run those in parallel, and that's what we do here with completable future. We run those in parallel, but then our roster task, it will need to wait until both of them complete. So it does just that. I mean, it just combines game futures and combine player futures. That it means that the roster task will only be executed once those two are complete. So this is something that you can do to optimize your execution. So to summarize, LinkMove is an embedded model-driven ETL. It has a built-in anti-corruption layer in the form of extractors, extractor XML files. It reuses your target Cayenne model. It is described very well in terms of domain-driven design, but by itself, I mean, there's nothing domain-driven design about it. So it actually probably breaks some tenets of that, but the terminology of domain-driven design actually helps to explain, how it's different from any ETL solutions out there. So essentially, it just helps us to explain that we're not about data warehouse, whatever. So, but this is at the bottom. It's just a data copy solution that is, that has developers as its intended audience, and not admins, not anyone, but developers. So this is where we are on GitHub, and if you have any questions, I'll be happy to answer.
For me, this is very new and interesting, and I'm trying to process it. So let me. I saw on your first chart 4 different bubbles. I think one of them was the website, the other was.
Yeah. Oh.
Yeah, so you got website, scheduling, venue operations, and officials management. And our client, in this case, is a sports team, right?
So no, I mean client. So it's sports organization like National Hockey League, for instance, or so.
So this is the national. Let me see if I can.
That's a league that has multiple teams. So here, like if we're talking about this specific domain, this is a sports organization. That's I mean, I should have probably specified that that's actually an organization that runs a championship. It's not just a single team. So it deals with schedule. It deals with all those things.
Yeah. Okay. So it's
organizing the games essentially.
It's the league.
It's a league. It's a league.
And we see these 4 bubbles, but what I'm thinking to myself and trying to understand the problem you're solving, each of those 4 bubbles really could be considered a client of their own, like a sub-business unit within the bigger business unit.
Yes, they are, and they are.
And so let's just take one. Let's say the website group.
Mm-hmm.
When you're doing work for them, they say, well, we need this, that, the other. If you had this huge data model that covered everything, you would have to pull in other groups and discuss things.
Yes.
It would slow you down.
Exactly.
You want to, for that website group, you want to say, okay, we're going to add this to the game entity, we're going to do this to the game entity, do these different things, and then later you'll say, okay, we went nuts there this past week, but we need to bubble it to these other places. So it allows you to be, I'm trying to figure out what's going on here. Just correct me if this is not what's happening, but I think what you're doing is allowing you to be very proactive for each of those groups independently, going in different directions.
Yes, this is a goal.
Yeah.
This is a goal to decouple, different contexts within an organization, and just whenever you're a programmer or a business user, you sit within a single bubble, and you don't cross this boundary until you need to borrow some data or whatever. Yeah, so you got it right.
Check. So do you have, go on to the next slide if you don't mind. We know you have a circle in the middle there. There you go, thank you. Do you have any words of wisdom about what point of view you would take at that point? Because I can see from the scheduling point of view, you're doing something very different than you are from the website point of view. And, from one side it's going to be ours, and from the other side it's going to be theirs. And you quickly swept through that. I was just wondering if you had any like insight into what perspective you use mentally.
So essentially, once you've already established the separation, so these are your subsystems, right, that are developed independently, and they have entire stack, including the data store. From there you need to do actually both. So first, each system, it needs to understand, of course, it better strive to understand whom it serves. So if it provides data to other systems, it shouldn't be just sitting there and just like, okay, so here's your database login, and so it also serves some business goal, and usually you would build some APIs around it, but sometimes you do, sometimes you don't, but it doesn't mean that you shouldn't. So you need to understand, like, really, like, if you are within this bubble, like, what is the goal of that bubble? So, like, what do you produce? So what, and if you produce the data for other people to use, then yes, I mean, like, go ahead and build an API. But maybe you are not. I mean, maybe you're some HR or whatever. So, like, you don't think about that somebody wants your data, for instance. Or you do, but you don't have resources on your schedule to actually go ahead and implement an API, or you don't understand every consumer out there, and you may be not ready to provide an API that's like stable enough, for instance. So this is where this helps, because you just when you are on the consuming end, it eliminates lots of a dependency, from the producer.
Right. So to put that, so if you're consuming, do you consume it in your terms?
Yes.
So that's
as a result, you're consuming. As a result, you're consuming in your terms.
If I'm a website person, I'm consuming from the scheduling. I put it in I want this from you. So it's up to the scheduler to essentially convert the terminology to what the request is?
So it's up to the consumer to do the translation of that model to the target model, to the consumer model. So yeah, it pushes it to the consumer.
So the consumer needs to know enough about who it's they're taking it from to say, okay, you have this available to me. I'm going to convert it into my terms.
Yeah, and this is where, encapsulation breakage happens because, yeah, you need to understand that system, you need to understand how the database is done, and, it can be a legacy database and whatever.
I have one other question. I do a lot with education, and I've been really blown away with these systems. I have supervisory unions, school districts, and they're all using these systems. And I've contacted these people about, gee, do you have a REST interface? Do you have some API? And they're all like,
yes.
what? We can give you CSV files, and we can take CSV files. We'll give you an FTP address.
Exactly.
So have you approached this? I end up with dealing with FTP servers with lists.
I mean, we're dealing with this all the time. We actually have. It wasn't on a slide because it hasn't been open source yet, but we have an FTP connector.
I noticed you had CSV files. In
yeah,
there.
I have CSV, and we consume CSV files over that. So here we go.
And I've created a whole little agent that just uses property files to parse CSV files.
So this is essentially, this is a ream to rule them all, essentially. So yeah, we've all done that. I just try to generalize the solution. There's a question there.
Hi. So I guess this is the follow-up to that. So if you extracting the data on one end and you cannot get to the destination on the other end, do you have like an established policy? How do you transfer the data from the source to destination? Like in this example, you could access both databases from the same server, right? But if it's like networking is not available and it's behind the firewall somewhere in a different warehouse.
So like in practice, we had to deal with it, and essentially since the transformation is owned by the target system, so that's where it all starts. So the target might actually fire up, some PM may fire up an email to the infrastructure team to ask to like open a hole in the firewall. So this happened. Of course, we're thinking about like multi-stage operations where, yeah, we can like set up some intermediate server or just, yeah, put it on premises in the source and then just somehow send it across, yes. Yeah.
There is no established system as of yet.
Yeah. So but we've been thinking about it a lot. I mean, definitely. But we were lucky that we didn't have to deal with it just yet. We got all the firewall requests approved.
So in terms of like reading CSV files, for example, heaven forbid, which I do all the time, how sophisticated? You showed some very, very basic examples of manipulating the data for the transfer. How sophisticated is that mechanism right now in terms of, I get situations like if this is null, then do this one, or combine these two, and that level of logic, is that integrated at this level, or would you recommend it at another level?
Okay, so like CSV Extractor itself is very simple, so it just, it gives you the data, but then with the listeners you can write custom logic to do that. So we understand that we cannot handle like every case of bad data, so essentially we just let a Java programmer to do it per task. And if some patterns emerge as a result, some typical validations that are useful everywhere, we'll be happy to incorporate that.
Right, because I'm in this situation where I end up with one FTP site with one set of data files and its own manipulation. Like, the rows are in different orders. The resulting data is the same, but then I end up with another one with a different set of CSV files with different manipulation.
Right.
And the same interface on both of them. So I really want the logic to be contained in data files on that FTP site, essentially. You know what I mean?
Yeah, but then you just write two tasks, essentially, and in each task you will have different listeners that is specific to that source. It will transfer. It will get into this pipeline somewhere in the beginning. So after acquiring the data, so we just got the sources and like. Somewhere here you would put a listener that actually cleans up the data before it goes further into the pipeline. And the rest of the pipeline will be the same, will be shared by your both tasks.
Thanks for that. That was a great presentation. At UCLA, we have a situation where we have a central data repository, and they're developing a new one right now, and it's specifically targeted at keeping metadata about what is a recent insert, what is an update. So you can have repeated rows that apply to the same object essentially, but it'll have metadata about insert, update. It looks like your tool is really flexible in that you could describe the SQL yourself for exactly which records you want. You could extract the inserts first, the updates later, and run the updates against the same object in your database.
So essentially, I mean, it does synchronization. So if its object is if there is a mix of inserts and updates, it will go in the same transaction essentially.
Exactly.
Yeah, but that's how it is. Was that the question? Or?
Yeah, I was just trying to smooth it out in my mind. And then also the mappings, because you have the mappings there, what I would want to do with a lot of these situations is collapse some of these records and flatten them into the same table. And
yeah, and hopefully SQL can help you a lot before you even get into Java and listeners and stuff.
right. In place of the SQL, can you also choose to use cayenne expressions or?
You can in the listeners.
Okay.
So yeah, then once you're out of Extractor, you get into this diagram, and then you just start writing your listeners that can do really anything.
Okay.
So that's
Fantastic.
more questions. All right, thank you.